Hello friends, in today's video, we shall see the mathematical derivation of a Cobb-Douglas production function for which the elasticity of substitution is equal to 1. This is also one of the properties of Cobb-Douglas production function. We know the general form of a Cobb-Douglas production function is Q is equal to AL alpha K beta, and the formula for elasticity of substitution is percentage change in the K by L ratio divided by percentage change in the marginal rate of technical substitution. Now this formula can also be simplified and written as sigma is equal to delta K by L divided by delta MRTS of labor for capital multiplied by MRTS of labor for capital divided by K by L. We know that the marginal rate of technical substitution of labor for capital is equal to MPL by MPK. So, differentiating the Cobb-Douglas production function with respect to labor and capital, we get marginal product of labor, that is alpha AL raised to alpha minus 1 K raised to beta, and the marginal product of capital, which is beta AL alpha K raised to beta minus 1. Substituting these terms onto the equation, we get alpha AL raised to alpha minus 1 K raised to beta divided by beta AL alpha K raised to beta minus 1. By splitting the terms L raised to alpha minus 1 and K raised to beta minus 1, we get alpha AL alpha L raised to minus 1 K raised to beta divided by beta AL alpha K raised to beta K raised to minus 1. Here AL alpha and K raised to beta will get cancelled out, and finally we get the marginal rate of technical substitution of labor for capital as alpha L raised to minus 1 by beta K raised to minus 1. Now since the exponents are negative, we shall write the reciprocal of the same, and it can be written as alpha K divided by beta L. Now since MRTS of labor for capital is equal to alpha K by beta L, then delta MRTS of labor for capital will be alpha by beta multiplied by delta K by L. Substituting this term onto this equation, we get sigma is equal to delta K by L divided by alpha by beta multiplied by delta K by L into alpha by beta multiplied by K by L the whole divided by K by L. All these terms will get cancelled out, and finally we get sigma is equal to 1. Hence, it is proved that for a Cobb-Douglas reduction function, the elasticity of substitution will be equal to 1. So, when representing a Cobb-Douglas reduction function in the form of an isoquant, we get a downward sloping and convex shaped isoquant. Now we can prove the same in another way, that is we have already found out that MRTS of labor for capital is equal to alpha K by beta L. So from this we can write K by L is equal to beta by alpha multiplied by MRTS of labor for capital. If so, then delta K by L will be equal to beta by alpha multiplied by delta MRTS of labor for capital. Now from this equation we can write delta K by L divided by delta MRTS of labor for capital will be equal to beta by alpha, and from the first equation, we can write MRTS of labor for capital by K by L will be equal to alpha by beta. So, substituting these two terms onto the formula of elasticity of substitution, we get sigma is equal to beta by alpha multiplied by alpha by beta. Here both alpha and beta gets cancelled out, and we get elasticity is equal to 1. So, using these two methods, we can prove that the elasticity of substitution is equal to 1 for a Cobb-Douglas reduction function. If you like the video, do subscribe to my channel and share the videos to maximum. Thank you.